below that line, right? So this green interval down here on the x-axis between 1 and 9 would be where this absolute value function was less than 4, right? Or if we asked where is it greater, then we're asking for the intervals greater than 9 and less than 1, right? So that's kind of graphically what we're doing here. So let's talk about the method. And there's actually 2 methods I'm going to show you, and you can choose which one you like. Here's one of them. Here's what your textbook says, and I'll show you a different one in addition to that. So how to, given an absolute value inequality, solve the absolute value algebraically. So first, find the boundary points by solving the equality, and then test the intervals created by the boundary points to determine where it's less than or equal to b or greater than or equal to b. Okay? And the second one I'll show you by doing this example. We'll do both methods for this example. So here's solve x minus 5 is less than 4. Let's go to the webcam. All right, so here's our equation, our inequality. Solve x minus, the absolute value of x minus 5 is less than 4. Okay, so what they suggest to do is, solve this equation, okay, just like we did before. And how do we do that? Well, we say x minus 5 equals 4, and x minus 5 equals negative 4. So this is a good point. A mistake that many students make on this is they change this sign to be positive. No. The expression inside the absolute value sign stays the same, okay? It's the sign on the other number. 4 and negative 4 is a sign that changes, okay? So just a little warning that many students make that mistake. Okay, so now let's solve this. We get x equals 9, and we get x equals 1. So that gives us 2 boundary points. Okay, so to me, this helps a lot, is to put these on a number line, 1 and 9. And these have broken the number line into 3 intervals. And now we choose a value in each of these intervals. So let's say 0, choose an easy one. So if x is 0, is this true? Let's see, the 0 minus 5 is negative 5. So the absolute value would be 5. Oh, sorry, we go back to our original inequality. X minus 5 is less than 4. Okay, and we see if that's true. So 0 minus 5 is negative 5. The absolute value is 5. Is that less than 4? No. How about something in between here like 2? 2 minus 5 is negative 3. The absolute value of that is 3. Is 3 less than 4? Yes. So this interval works, and we can guess that this one's not going to, but let's just try 10. 10 minus 5 is 5. That is not less than 4. So that interval does not work. Okay, so we know our answer here is this interval here between 1 and 9. Now, using interval notation, what kind of parentheses or square brackets am I going to use? Well, our original inequality just had a less than, so we're just going to use parentheses because 1 and 9 aren't included. Okay, so that would be our answer. So that's one way to do it. You solve the equation and you check a value in each of the intervals and figure out which intervals this is true for. Okay, here's the second way to do it. So my original equation, x minus 5 is less than 4. Well, what does that mean? It means that x minus 5, the distance between those is less than 4. So that means this is going to be x minus 5, that expression is going to be between negative 4 and 4, right? So now I can solve this inequality all in one step. I'm going to add 5 to all 3 parts of that inequality, and I get 1, and then x, and then 9. Ooh, I'm just done in one step, right? X is is greater than 1 and less than 9. I could, again, write it in interval notation like that. So for problems like this, I think this is a little bit easier, okay? However, what if instead we had this problem. The absolute value of x minus 5 is greater than 4. Okay, so I switched the inequality here. Okay, if that was the case, this method would be exactly the same, except I'd solve the equation 4 and negative 4. I'd get the boundary points 1 and 9. So I'd have my 3 intervals to check here. But now when I plug in 0, 0 minus 5, the absolute value of that is so 0 minus 5 is negative 5, absolute value is 5. Yeah, that works, right? This one's going to work, and that one doesn't work. So now my interval would be negative infinity to 1 and 9 to positive infinity. Okay? Let's try this method. Let's see, what does it mean for this distance to be greater than 4? Well, again, I really am going to have 2. So what does that mean? I need x minus 5 to be greater than 4. That distance to be greater than 4. Can I write this in one? Is it less or less than negative 4? Okay, so it's going to be similar here, but the inequality signs are flipped. Okay, this distance has to be bigger than negative 4 in magnitude, or bigger than 4, sorry, less than 4 in magnitude, or bigger than 4 over here. So now if I solve this, I'm going to get 1. So x has to be greater than 9 and less than 1. What does that mean? Okay, really there's 2 separate intervals we're talking about here, right? So I have to write one inequality for this and one inequality for that. So again, I'd end up writing these same things, but I'd have to write x is less than 1 would be this interval, and x is greater than 9 is that interval. Which of these methods makes more sense to you? Only you can know. You can decide which way you want to do this. I think this way that the book teaches you is a little bit more straightforward and always isn't more confusing or less confusing if you have a greater than or equal or less than sign. Okay? If you have a greater than sign, this method is a little bit easier to mess up on. Okay? But if it makes sense to you, you can use it. All right, so let's look at a graph. This is actually the original graph that I showed you, right? The interval that we had was from 1 to 9, and this was the equation that we just solved, the absolute value of x minus 5. So it was less than 4 on the interval from 1 to 9. Okay, let's do one more that's a little bit more complicated. All right, so given this function, determine the x values for which the function values are negative. So they're trying to be sneaky in the way that they state this problem, okay? So they're determine the x values, that just means the interval, for which the function values are negative. So what does that mean? That just means they want us to say negative 1/2 absolute value of 4x minus 5 plus 3. They want to know where this is less than 0, right? And it's going to be just less than because 0 wouldn't be negative. That would just be 0. Okay, so it's a little bit more complicated. Again, we have the first thing we need to do is we can't do anything until we isolate this absolute value. Can I distribute this minus 1/2 into the inside of this absolute value sign? No, we can never do that. We cannot distribute numbers in, okay? So don't try it, even though lots of students do. So first thing, let's bring this negative 3 over here. So it's going to be less than negative 3. We're just adding, or just subtracting, so we don't have to change the sign. Okay, but now we need to multiply by negative 2, right, to get rid of this negative 1/2. So I'm going to multiply everything by negative 2. So that's going to give me absolute value of 4x minus 5, and negative 2 times negative 3 is going to be 6. I've multiplied by a negative value, so I'm going to have to flip this inequality, right? Don't forget that part. Okay, so now we've isolated this. 4x minus 5, the absolute value is greater than 6. Okay, we can decide which method we want to use. Let's just use the book method. Okay, let's find the boundary points and test something in each interval. So I'm going to break this into two problems. 4 minus x equals 6. 4 minus 5 equals 6. Or, sorry, I think I said both of those equations wrong. 4x minus 5 equals 6. 4x minus 5 equals negative 6. Okay, and now we just solve these linear equations. I'm going to get 4x equals 11. X equals 11 fourths. This is going to be 4x, so minus 6 plus 5 is minus 1. And then x equals minus 1/4. Okay, so let's see, these boundary points, here is negative 1/4 and here is 11 fourths. Something in between is 0. That looks like an easy one. So we need to go back to the original equation and see if that works. And you can try doing it in your head, but you make less mistakes if you write it down. So let's just try 0, negative 1/2 of 4 times 0 minus 5 plus 3 is less than 0. Let's see, is this true? Negative 1/2 times absolute value of negative 5 plus 3. Negative 1/2 times 5 is going to be negative 5/2 plus 3 is less than 0. Is that true? No, because this is greater. This is 6/2, right? So this is not true. So 0 doesn't work. So since this is an absolute value function, we know it's a v, right? Either the inside is going to be true, and these are both wrong, or the middle is false, and the outside two are both true. Okay, so you really only need to choose to test one interval if it's an absolute value function that you're working with, because we know what the graph looks like. Later on, we'll do this with polynomials, and then we really have to check every interval. But for now, we only have to check one, and we know that it's going to be less than negative 4th or greater than 11 fourths. So can you write it in an interval notation? To the left is negative infinity to negative 1/4, union 11 fourths to positive infinity. Okay? So let's look at the graph. Sure enough, okay, so we see the graph was inverted. A lot of stuff happened to it. It got shifted to the right, it got shifted up, it got inverted, and it looks like it was also vertically or horizontally stretched or compressed. And we can see all that from here, right? We'd have to factor out this 4 to see, we can see that, so it was horizontally compressed by a factor of 4, and it was shifted to the right by 5 fourths. It was shifted up by 3, and then it was vertically stretched by a factor of 2. So it's a combination of horizontal and vertical stretching. Would not ask you to graph this, okay? And then this minus sign tells us it was reflected. Okay, but the point is we found these two these two boundary points, negative 1/2 and 11 fourths, right? And we found that here it was below the x-axis and here it was below the x-axis. Okay, so that's how you solve inequalities. Let me know if you have any questions.